Hey, what's going on, guys? So Google recently announced its new successor to C++ called Carbon. And this is a language that is experimental, so it's not like you're going to go out tomorrow and get a job writing Carbon. But I've been looking into it for the past few days, and I figured why not make a crash course just for fun for people that like to learn new stuff like myself. So what we're going to do is talk a little bit about it, and I'm going to show you how to get set up because it's not completely clear in the docs. And then we're going to look at some basic syntax from arrays and tuples to functions and classes and all that good stuff. And even if you've never written a line of C++, that's absolutely fine. The syntax, at least on a basic level, is pretty simple. So if you know any language at all, then most of the stuff will be pretty easy for you to understand because we're not really going to get in deep with this. And I've seen a few other videos on YouTube. Fireship has a really good one talking, it's basically a summary of Carbon and what the plan for it is and so on. And then you have a lot of clickbaity stuff, articles and videos talking about how it might kill C++, and you're always going to have that type of stuff on the internet. But what I want to do is just take an objective look at it. I'm not praising it. I'm not bashing it. I'm not endorsing it. I just want to just teach it, or what we know so far of it. All right, so it is an experimental successor to C++, and a lot of people might say, well, what about Rust? Rust is, can be used for a lot of the same stuff that C++ is used for. And while that's true, Carbon has bidirectional interoperability. So you can write C++ and use C++ libraries within Carbon and vice versa. It says right here, interoperate with your existing C++ code from inheritance to templates. It's fast and scalable. I'll go over some of the plans and stuff for it in a minute. But down here you can read, I've already read all this, but you can read why they're doing this. And I'll just kind of summarize this for you. So there has been some precedents for this dynamic. You have JavaScript to TypeScript, Java to Kotlin, Objective-C to Swift, and now Google is trying to do that same type of thing with C++ to Carbon. Now, will it succeed? I have no idea. There's been other languages that have tried to do the same thing. From what I can see in the C++ community, there does seem to be quite a bit of resistance and pushback, but that's to be expected. When you have developers that have been working with C++ for years or decades, a lot of them don't like change, especially if they don't see enough reason for it. And if you read more on this page, they do say that it's relatively easy to work with and migrate large C++ code bases. And I think that's a big reason why Rust isn't a direct successor. Since Carbon can interoperate with C++, they're saying that's possible. So some of the reasons why they feel C++ needs improvement in the modern age, I guess, is because it's racked up what they call technical debt over the years and is struggling to improve and meet certain developer needs. And they say that incrementally improving C++ itself is extremely tedious and difficult. And Google stresses that the best way to address these problems is to try and avoid inheriting the legacy of C or C++ directly, and instead create a new language with some solid foundations like a modern generic system, modular code organization, and a consistent and simple syntax. And if we look at some of the language goals, we're designing Carbon to support performance critical software. Of course, it has to match the performance of C++, or it's not going anywhere. Software and language evolution, code that is easy to read, understand, and write, practical safety and testing mechanisms, fast and scalable development, modern OS platforms, interoperability, and and migration from existing C++ code. So there are some specific things that they're trying to improve upon, one of which is memory safety. So C++ is not a memory safe, or it's not a managed language like C# and JavaScript and Ruby and most of the languages we work with. you have to manage your own memory, and there can be issues with bugs and with vulnerabilities. So this is the stuff that they're doing to combat that, and you can look more into this. And then also generics, they provide a modern generic system. C++ uses something called templates. You can still use C++ templates, but then you also have the ability to use generics as well. So those are just some of the things that that are being added here. And then there are some code samples. So if you look at this one right here, this is straight C++ code. It's just to, I guess, print the area of a circle. And then you have your Carbon code here, which does the same thing. And you can see it is very similar, but it does, to me at least, look a little bit cleaner and simpler. And then down here, you'll see that C++ code can be used within Carbon, and you can also call Carbon from C++ as well. And you can use any C++ libraries, which is nice. Now, as far as your opinion on this, if you think it's a good idea or not, I mean, that's really, that's up to you. This video isn't to bash or to praise it. I just want to look at it objectively. So to get started, there's a couple things you can do. One, you can, because there's no compiler yet, or there's no tool chain yet, so you have to use Google's build tool called Bazel, along with LLVM, which stands for Low Level Virtual Machine. So you can install those with Homebrew. If you don't have access to Homebrew, you can simply go to compiler-explorer.com and just choose Carbon, and you can actually write and execute Carbon code here, which is probably what I'll do. I am going to show you how to set this stuff up with Homebrew, but when we get into the actual syntax, I'll probably use the compiler explorer. Now, I do have another link in the description to this gist that I created, which basically has everything we're going to look at, from getting set up using Homebrew to packages, the main function, the print command, primitive data types, naming conventions, variables, basically all the stuff that I have in most of my programming language crash courses. So that's why I called it a crash course, because we're gonna get into that syntax. But let's start off, just in case you do want to install this stuff with Homebrew. If not, then you can just kind of skip this part. But I'm gonna open up my terminal. Okay, and then I already have Homebrew installed. I believe I already have this stuff installed as well, but I'll just go through and type the commands anyway. So we want to brew install, and the package is called Basilisk, so B-A-Z-E-L. And I'm probably just going to get a message that says it's already installed. Looks like I can update. Yeah, so it's already installed and up to date. All right, and then you're just going to want to install low-level virtual machine. So brew install LLVM. Again, I think, yeah, I already have this installed, and that'll probably take 2 or 3 minutes if you don't already have it installed. So once you get those two things set up, you just want to add this to your path. So we can just copy that. And again, if you're on Windows or something, just ignore this whole part of the tutorial. So we're going to just type that in, and then we want to clone the repo. So right here, we're just going to run git clone. So let's do that. Actually, is this where I want to put this? Yeah, it's we're in my dev folder. So what this will do is it'll clone it into a folder called Carbon Lang. So now I can cd into Carbon Lang, and if I do an ls, you're just going to see everything that is in this repository. Okay, and basically everything that I've learned so far has been in this repo, and a couple articles too. But you have docs, and then you have this Explorer folder. And if you go into test data, you can see examples for just about everything: functions, generics, if-else, pointers, all the stuff we're going to talk about. I basically learned from these examples here. All right, and if we look at, let's see, if we look at in the repo and we go down here to get started, where is it? Actually, we want to go to the, yeah, if we go right here down to get started, this is the stuff we just did, and then it's telling us to run the Explorer and to run one of the files in that test data folder. But what I want to do is just create a separate file to work in. So right here we can create a directory. I just called it sandbox. So we'll go ahead and say make directory sandbox, and then we'll cd into sandbox, and then we'll create a Carbon file. So let's say touch, and we'll say test.carbon, and then I'm going to open up VS Code in the home folder here. Okay, and then we should be able to run the Explorer. So let me just open this Carbon file up. Now what I'm going to do here, don't worry about it, I'll explain it all in a second. I just want to see if we can get this running, and you can copy this too. So we're going to say package sandbox API, and then we're going to create our main function. So function main, and that's going to be a 32-bit integer, so I32, and I'll explain all this in a minute. And then let's just return 0. We'll do a print in here as well, and just say hello world. All right, so I'm going to save this, and then I'm going to run this. If we look here, we can say Bazel run, and then Explorer, and then the name of the file. So I'll just copy that, and I'm already in Sandbox. So if we just run that, the first run is probably going to take a little bit, but after that it'll be, instant. All right, yeah, so that took about, I don't know, a minute and a half or so, and you can see we have build completed successfully, and we're printing out hello world, and the result is 0 because I returned a 0 from my code, okay, as you can see here. Now, if you followed along with this and all this works, you can use this for the rest of the tutorial if you want. As far as I know, there's no Carbon highlighting. There is this one here, but it doesn't work. I installed it, I tried it out, and well, there is downloads, there's no ratings. Yeah, I don't think this works, and then I couldn't find any other ones, at least for now. And I don't really like writing code if there's no highlighting. So instead of using this, and instead of having to run, and if you run this again, it should be instant. But instead of having to do that, I'm just going to use the compiler Explorer. All right, so yeah, I'm just going to go ahead and close that up, and we can close that up, and we can just run it in here. So let's see. I want to be able to see my output. So let's click on this right here, and yeah, so this will show us our output. Basically, this shows you exactly what I just saw in the terminal window. So let's just clear this up. I'm going to get rid of everything, and we don't have to click run or anything. It's just instant. And of course, this is not going to compile because we have nothing written here. Now I want to see if I can make this. Yeah, we can make this a little bigger, and now we can get started on learning the syntax. All right, so the first thing we need to do is create a package name. So a package is a group of libraries in Carbon, and it's a standard unit for distribution. The package name also serves as the root namespace for all name paths in its libraries. So we do have to add a package here, and we can call this whatever we want. I'm just going to call it Sandbox. Now, in addition to that, let's see. So each library must have exactly one API file. This includes declarations for all public names of the library. Definitions for those declarations must be in some file in the library, either the API file or IMPL file. So in order for this to work, we have to add onto this. Either IMPL or API. So we're going to say API, and we do need semicolons to terminate our statements. All right, now, if you've ever used C++ or even like Java, you have a main function, and that's basically your entry point. So if we look at the gist that I created, that's the next part, is the main function. So let's create that so that we can actually compile our code. Now, to create a function, we don't use the function keyword, we use fn. Okay, so we're going to say fn, and then the naming conventions, I'll go over that in a few minutes, but for functions, it's going to be upper camel case. So it's going to start with an uppercase. So if I wanted to call this main function, I would do, I would do it like that. I'd uppercase every word, but we're just going to call this main. Now, this is a statically typed language, and if you're, let's say, a JavaScript developer and you don't use TypeScript, that's probably new to you. So we do have to define the types for our variables, for our function returns, for any arguments that we pass into our functions. So this main function actually has to return an integer. Okay, it has to return a number. And usually that's going to represent your exit status. And 0 is going to mean that it's successful. So what we have to do here is first define the function type. And I'll just do a string just to show you that this won't work. So if I do string and then I return from this function, we'll say hello. And if we take a look over here, it says type error in return. In return type of main. Expected I32. So I32 is a 32-bit integer, and it's saying that we can't return a string here. It has to be, this should actually be like that, but this has to be I32, and of course hello is not an integer, so we're going to return 0, and now it should compile. So now you can see it compiled here, and we're getting a result of 0. And in C++, the main function returns an integer as well. Even if you don't explicitly return anything, it returns 0 implicitly. And again, that usually represents an exit status, and 0 is success. Okay, let's close that up. All right, so the next thing I want to look at is the print command if we want to print something out. So we'll go within the main here, and we're going to do print. And it's going to be an uppercase P because it's a function. So in print, let's print out a number of, a string of hello world. And of course we need our semicolon. And then we're still going to get our result of 0, and we're also printing out hello world. Now, if we want to print a number, if we put a number directly in here, or I should say an integer, we do get an error. It says type error in print argument 0. It expected a string. So if you do want to output a number, because this can print, we print strings here. So if you want to print out a number, what we could do is use a placeholder. So, and you might have seen this in other languages. So we're going to have these curly braces and put a 0 in that. And then after the comma here will be whatever we want to print out. And this could be like a function name or something like that, or it could just be an int. And now you can see that it's printing out 200 as a string. All right. Typically, you're not going to put all of your code in the main function. You're going to have different functions and run them from here. So what I'm going to do now is show you how we can create another function. So let's say fn, and we're going to say output, call this output text, and I want this to return a string, so we have to add here that we want this to be a string return, and then I'm just going to return from here a string of hello world. Okay, and then obviously we can come down here and we can call that. So let's say output text, and now that should, let's see, you know what, that's not going to print anything out because I didn't use the print command. This is returning something. So what I could do here is I could say print. I hate not having like autocomplete and stuff, but we could say print output text, and now you can see we're getting that hello world. All right, now if we have a function that doesn't return anything, like let's say we want to do the print here, so we'll say print hello world, and then down here we don't have to call print, we'll just call the function. We can do that. We are getting an error though because this function is no longer returning a string, so we can now get rid of it. Okay, so that's a void function, and we don't have to do, like in some languages you do this, void, that's going to throw an error. So we can just go ahead and get rid of that, that return. Now let's talk a little bit about data types. And we're just going to hop into the gist file for that. So let me scroll down here. Oh, and by the way, the reason that this file saved is because I did Command S. If you do that, it's just going to go ahead and download your file as a Carbon file, which is pretty cool. So let's see. We're going to look at primitive data types. And as I said, Carbon is a statically typed language, which means that we have to define our types. There is an auto type that we can use, and I'll talk about that in a little bit. But primitive types fall into these categories. So we have Booleans, which are true or false. We have signed and unsigned integers. So basically, signed integers are positive values. Unsigned are, signed is positive or negative. Unsigned can only be positive. And when we write the type, it has to be an I, so it's an I along with the size. So we have like an 8-bit integer would be I8, I16, I32, all the way up to I256, and these would be signed integers. If you want to use an unsigned integer, you would use U, but typically you're going to use signed integers, so you're going to use I, and 32 would be the most typical, depending on the size of the int. Now, we also have floating point types where we can do F16, F32, 64, and F128. Again, typically I would use F32. And then, of course, we have string types, which are, a string of characters wrapped in double quotes. You can't use single quotes. They have to be double. And you can also create multi-line strings using triple quotes. And I'll go over that in a little bit. Now, as far as naming conventions go, upper camel case is going to be used when the named entity cannot have a dynamically varying value. So things like functions and namespaces. And then lower snake case, which is just lowercase with underscores, is going to be used for variables. So when the named entity's value won't be known until runtime. And then I just put this table that I got from the documentation that shows you the different items or different entities and what the naming convention is. All right, now let's get into variables because we haven't done that yet. So let's hop over here and variables. Let's see, what should we do here? I'm going to get rid of. We'll still keep this output text function. And actually, let's keep the print, but instead of printing a string directly, we'll create a variable. So let's go up here, and oops, I can't use that shortcut. All right, so let's go in here and create a variable. Now, when we create variables, we use the var keyword, okay? And I know a lot of you guys, at least if you're a fan of my channel, you're probably a JavaScript developer. So this might seem a little weird these days because we don't really use var, we use let and const, and there is actually a let in Carbon lang, which I'll get into in a minute, so that's a little confusing as well. But we'll say var and then whatever we want to name it, and again, it's recommended that we use snake case here. So if I had two words like whatever, text hello, I would do it like that. So let's say text. Now again, this is a statically typed language, so we have to say what type of data is going to be in this variable. So we do that with a colon. When it's a function, we use the arrow like that, but when it's a variable, we use the colon. So let's say this is going to be a string, and then we'll set that to the value of, we'll say hello there. Okay, and then we should be able to just pass into the print here, the text variable, and we're calling output text right here. So you can see as a result, we're printing out hello there, and we still get our return of 0, meaning everything is okay. Now, when we use var, we can reassign the value that's in that variable. So I used var text. That means that I can reassign that if I want. I can say text equals, and then we'll say, I don't know, hello Brad. Okay. So if I do that, that should work. So I can see hello Brad printed out. Now, there is another keyword for variables, and that's if we want it to be a constant. Okay, so if we want it to be a variable that doesn't change. Again, for JavaScript developers, that would be const. and you would use let for variables that can be reassigned. However, in Carbon lang, we use let for constants. So I know that can be a little confusing, but if I were to, let's comment this out. And by the way, I didn't even mention comments. Comments is going to be just double forward slashes. But let's go ahead and change this to let. And we can see that that works. I'm getting hello there printed out. But if I uncomment this and I try to reassign it, it's not going to work. We get cannot assign to our value text. Okay, so just keep that in mind. So you're usually going to use var. In JavaScript, I always use const unless I know that it's going to be reassigned at some point. But I wouldn't recommend using let here all the time. I'd use var. I do the opposite. Use var unless I know that it's not going to change. Because typically, I notice that in most programming languages, constants aren't really called constants unless they're definitely never going to change. Like in JavaScript, you use const with an object because you don't directly reassign it, but you do manipulate it. Like you can change a property in that object. In most languages, it seems that constants are used for like a server name or your host or something like that, something that's definitely not going to change. No part of it, you're not going to manipulate it in any way. At least that's my view on it. So yeah, just I would say use var. I know that was kind of long-winded. Now I did mention that we could use auto as a type. I couldn't use it here on the main function. If I do that, that's not going to work. Main must have an explicit type. But if I wanted to create a variable called x and set it to auto, let's set that to a number. Okay, so we can see that that works, that compiles. And if I change this number to a Boolean, let's say false, that still works. If I change it to a string, that works as well. So there might be cases where you want to use auto. All right, now we can also have global variables. So outside of the function scopes here, I could go up here and create a variable. So let's say var, I don't know, we'll just say var x, and let's say that's going to be, we'll do I32, and let's set that to 100. Okay, so that should, yep, so that compiles. And then if I come down here, now remember, if you have any experience with any languages, we have function scope, right? So this x that I created here is not, I guess we'll talk about scope now as well. So this is not going to be available. Let's just change that to y for now. And if I come up here and I try to print, let's try to print y. Okay, so that's not going to work. Wish we could see this whole actually, there we go. So could not resolve y, even though I defined it down here, because this is a different function. These have separate scopes. However, this x up here is a global variable, so I should be able to print x. Let's see, type error and print. Well, that's a number, so I would actually have to do, I'd have to do this. But that should print, yeah, so you can see now we're printing 100. So we can have these global variables. Another thing I wanted to mention was multi-line strings. So if I wanted to do that, I know this code is a mess, but I'm just kind of showing you one thing at a time here, but I guess we could clean it up. So I'll get rid of that and that. Okay, so if I wanted to do a multi-line string, let's actually change this. Let's do 3. So we're going to wrap this in 3 double quotes. And if we do that, then we can put these on separate lines. Let's put this down here and say hello world, hello Brad. All right, so now you can see we're not getting an error, and it's printing these 3 lines out. So that's a multi-line string with triple quotes. Now, as far as function arguments go. I want to talk about that next because we have these functions, but we haven't looked at passing in, creating any parameters and passing in arguments. So what we'll do here, let's actually get rid of output text, and I'm going to create another function, and I'm going to call it add. Okay, something we typically see in these crash courses. So this is going to be an int, let's say I32, and let's say we want to pass in here two numbers. So we're going to say var x. Actually, var, I believe var is optional here. Let's try it without var. So we'll say x. Now we do have to add types here, remember that. So let's say I32 for that, and then y, we'll say I32, and then of course we want to just return here, let's say x plus y, and then we'll go down here. We could print this out, or we could just return. Since we're returning an int, we'll just return add, and let's pass in 1 and 2. So now we get result 3. Okay, so we just create a function. If you've used TypeScript, I know because again a lot of you guys are JavaScript developers. If you've used TypeScript, this should look pretty familiar. But I believe, yeah, I can also put var. I'm not exactly sure that if there's any difference or if this is just if this is just preference or what, but we can put var there as well. All right, so the next thing, and just to show you, if we wanted to print out a string with this function, we could do that. We could say print, and in here we could say, let's say 1 plus 2 equals, and then we would put our curly braces 0, and then whatever we want to replace that curly braces 0 with, we would put here. So let's say add 1, 2, and then we see this string 1 plus 2 equals 3. So now we're going to look at arrays. So I'm actually going to get rid of that. We're just going to do this in the main function here. So let's return 0, and then we'll get rid of this line here, and let's look at arrays. And all these examples I have in the snippets here. So everything we're going over is in that file. So arrays are data structures that hold multiple values. When we define an array, we have to define the type of data that's going to be in the array. We also have to define the size. So again, for my JavaScript developers, that we don't have as much freedom with arrays as we do in a language like JavaScript. So let's create a variable, and let's do an array of integers, of numbers. So we'll do var I underscore arr, and we're going to add the type here. So again, we have to do the type and the size. So in brackets, we're going to have the type that we want in this array, which is going to be a 32-bit integer, and then we do a semicolon here, not a comma, a semicolon, and then the size of the array. So we'll say 5. Then we're going to set it to a set of parentheses, and then we can put, I'll just do random numbers in here. And if I just stop there and we look at the error here, it says type error in name binding. I32 4 times is not implicitly convertible to I32 5 times. So that means I'm missing one here. So I'll put in, let's do 19. Okay, so that should work, or that should compile. Now let's say I wanted to do a string. We'll say var, you know what, let me make this, yeah, there we go. So let's do var, we'll say s underscore arr, and let's say I just wanted to have 2 strings in here, so I would do the type string semicolon and then 2, and then I'll set this to a set of parentheses and then add my strings in here. Okay, and that should work. Now, if I want to print out a specific value, like let's say I wanted to get this 43 right here, let's say print, let's say print, and then we'll go add that because this is going to be a number. So let's take the name of the variable, which is going to be I_ARR. And remember, arrays are 0 based, so it's going to be 0, 1, 2, 3, 4 for the indexes. I want to get 43, which is going to be the one index. So if I do that, you'll see that it'll print out 43. Okay, if I wanted to get the hello from the string, then I could do s_array, and I want to get the 0 index, which is going to be the hello string. Okay, now in addition to arrays, we have tuples, which are another way to store multiple values. So let's say var t. Now with tuples, we have to define the types, but we don't have to define a length, so it's not as strict. So let's say, actually let's call this t_1. And as far as the type goes, let's just say auto. So if I say auto, then I can put whatever I want in here. We'll do 1, 2, true, and hello. So that should work. Now if I do var, let's call this one t_2, and I want to explicitly define the types, that's going to go in parentheses here. So let's say we want a string, a bool, and then I32. So then that would have to match if I do hello, so that's a string, then a boolean, and then an int. Okay, now if I change this middle one here to an integer, we should get, yeah, it's basically just telling us that it's not matching, you know, it's not binding to the correct types. Now to access the value by index is just like with an array. So let's say print, oops, we need uppercase P, print, and let's take, so this hello right here, that's going to be, this is 0, 1, 2, 3. So we can do t1, the name of the variable, and then the index of 3, and we should get hello. Okay, so we access it just like we would with an array. So we can also convert tuples to an array. So if I say var t, auto, set that to just 1 and 2, and then we should be able to say var a, and then as far as the type, actually we'll just, yeah, we'll do auto, and should be able to just set that to t, and then down here for the return, let's say we want t0, which should be 1, and then we'll add a1, which should be 2, and we get a result of 3. All right, now another data structure that we have to work with are called structs, S-T-R-U-C-T-S, structs for structures. And this is like a JavaScript object or a Python dictionary, basically key value pairs. So let's get rid of this stuff. And let's create, we'll say var person, and I'm going to set the type to auto. And the syntax for this is a little weird. It's going to be dot and then whatever we want the key to be. So I'll say name. And unlike JavaScript objects where we have a colon here, we put an equal sign. We'll say Brad, and then let's do we'll say location .loc for location, and we'll set that. Oops, still in JavaScript mode. Okay, so that should work. And then if we do, well, that's not going to work because I got rid of the return. So we'll say return 0. And then let's do a print. Okay, so now if I want to print out the name for this person, struct, then I could do person.name. So there we go. So now it's printing out Brad. All right, and I could change that. I can change these values as well. So if I come down here and I say like person.name, and I change it to John, and whoops, if we print that out, we get John. Now if I use let here, I just want to see if we change this to let, cannot assign to our value person name. So normally in something like this, if this were a JavaScript object, I would use const here, and we would still be able to change one of these values. But in this case, we're going to use var. Now, I used auto right here, but in most cases, you should define your types explicitly. So we'll just get rid of this, and let's create a struct with types. So we'll just say var and then p, so for points or coordinates. And I'm going to say that I want two 32-bit integers. So the types we're going to put in curly braces, just like the structs themselves. And then the name of the key, so I'm going to use x and y. So I'll say that x, I want that to be I32. And then y, I want that to be I32. And then we'll set the actual values. So here we'll say .x equals 1. And then we want to put a comma, and then .y equals 2. So that should work. And then let's come down here, and we'll go ahead and print out. And I'm just going to, I'll say value, colon, and then what I want to print. And what I want to print is going to be p, so that's the name of the variable for the struct, and then the key that I want, which is going to be x, and that's going to print out the value of 1. If I change the value here of x to 100, then it should print out 100. Okay, so those are structs. Now, we also have classes, so what I'm going to do here is, let's get rid of that, and I'm going to go above the main function here, and I'm going to create a class. So class, the class keyword is actually going to be lowercase, and then the name of the class will be uppercase. So I'm going to say class point. And then classes are structures that you use. You create objects from classes, and if you know literally any other language, you probably know at least the basics of classes. They can have properties, which are just like attributes, and they can have methods, which are functions. So let's say for this point class, any object I create from this point class, I want them to be able to have an x and a y attribute or property. So I'm going to define my properties here with var, we'll say x, and then the type, which is going to be I32. And then I also want to have a y value, and that's going to be an I32 as well. Okay, now down here, if I want to instantiate an object from that class, I'm going to create a variable. Let's say var p, and then for the type, I'm going to use the name of the class, or the name, what kind of object is this? So it's going to be a point, right? And then we'll set that to some curly braces here, and let's say .x, and we'll set that to, let's say 100, and then .y, we'll set that to 200. Okay, and then if I want, let's do this, let's say print, and we'll say result, and then let's take py, or p.y. So what I'm doing is taking this p object, and I'm taking the y attribute, which is set to 200, and then we'll subtract p.x, which is going to be 100, and I'm going to get my result here of 100. All right, now you can also have functions inside of classes, and those are called methods. Okay, so let's come in here. Well, actually, I should say that there is methods and there are functions, and there's a difference. We're going to look at methods first, which are going to be methods we can call on the actual object. What we did here is we instantiated a p object. And this could be anything, any kind of object. It could be a user, maybe that would be more clear, but or I should say a point object. P is just the variable. And if you know other languages, this is going to make a lot more sense than if you don't. So let's create a method. We're going to use the fn keyword, and let's say we want this to get the x value. So we're going to call it getX. And then I want to be able to access the properties of point within this function. Now, in a lot of languages, you use the this keyword, okay? What we do here is in our brackets, we're going to say me, and then colon, and then the class name of point, okay? And then this is a function, so we need our parentheses, and then we need to define what this is going to return, which is going to be a number or an int. Okay, and then we can use this me variable in here to basically access the current class or the current object. So in here, let's say return me.x. Okay, because we're basically saying this class or this current object that we're in, and then the x value of that. So if we come down here, let's see, let's get rid of this, what we want to print out, and let's say p.getx, which is a function, so we want to do that, and notice we get 100, because that's what we set this value, this p variable, which is a point object. We set that x property to 100, and then this this method is getting that x value. We could do the same thing with the y value. So let's say get y, and then we just want to get me.y. And if we come down here and change that to get y, we get 200. All right, so those are methods. Now, functions are going to run not on the instantiated object, but on the class itself. All right, so let's come in here and let's create another function. So this is kind of like a static method, I would say, in other languages. But we're going to say function origin, and it's going to have a type of point, and then I'm just going to return. So let's say return .x. So basically going to set x and y to 0. Y equals 0. All right, now this origin function, we don't call on p. So we're not going to do p.origin. We're going to do point, the actual class of point. So let's come down here and let's say, so this variable of p, let's change that. So it is going to be point, but we're going to set it to the class name of point and then .origin. Okay, and then if we come down here and let's just print out p, I'm sorry, px, p.x or y, whichever one you want to print out, they're both going to be 0, okay, because that's what we set in this function. If I change x to 300, then that's going to print out here. All right, and again, if you're not familiar with object-oriented programming and classes and objects, this is going to be really confusing. But if you are, then, I mean, it should be pretty simple. Okay, so the next thing I want to look at are pointers. So a pointer is a variable that holds the address of another variable, and we can use the ampersand operator to get the address of a variable. So let's get rid of all this. And again, this stuff is all in that gist file if you want to reference that. Now let's go right in the main here, and I'm going to create a variable called x, and let's give it a type of i32, and I'm going to set it to the integer of 5. Okay, now what I'm going to do is take that x variable and then change it to 10, and let's print out, we'll say print, and let's just say x colon, and then whatever the value is. So we just have to add here x. Okay, so right now we get x10, right? Well, it's 5 at first. Let me just get rid of that. So it's 5, and then we're changing it to 10. All right, now what I'm going to do is create another variable, and I want this to be a pointer to the value of x. So we'll call this p, and then we're setting a pointer, so when we do the type, we do whatever the type is, and then an asterisk. And then we set it to ampersand, and then whatever the variable of the value we're looking to get. So we're going to say ampersand x. So now that I have a pointer pointing to X, and the P here is arbitrary. I just called it P for pointer, but this could be anything. You call your variable anything. But it's pointing to whatever this X is equal to. So if I were to take that pointer by saying asterisk P, and then I set that equal to 7, and then we look over here, you'll see that X is now equal to 7. All right, we didn't explicitly set X to 7 anywhere, but since we have this pointer and then we updated the pointer value, that's going to update that X value. It's pointing to the same place in the heap in the memory that X value is pointed to. All right, now if I were to create another one, let's say var q, and set that to I32 asterisk as the type, and then I'm going to set it to a pointer of P. So we'll actually do ampersand asterisk P. And then if I come down here and I say I want to set asterisk Q equal to 100, and we look over here at the value of X, now the value of X is 100. Okay, so we have these two pointers. They're different variables, but they're pointing to the same place that X value is pointing to. All right, so hopefully that makes sense. Now you can also have pointers that are structs. So let's get rid of this, and let's say var X, and we'll set this to auto, and then let's set this to a struct. So we'll say dot X 10, and let's say dot Y. Whoops, I'm using JavaScript here. We want to say equals, and then Y equals 30. Okay, and then if I create a variable, let's say P, and the type is going to be I32, but it's going to be a pointer, so we want to put an asterisk here, and then we can set it to ampersand, and then let's do X. So X is the name of the variable. Actually, maybe we shouldn't use, that's kind of weird. We'll call this S. So let's set this to S.X. Okay, so I have this P pointer pointing to this value, this S.X, which is 10. So if we come down here and we return S.X, the result is 10. Now if I were to update, let's say, that P value, so we want to update that pointer, so we'll do asterisk P, and let's set that to 55. And now what we're going to see is that S.X value is now 55, okay, because I had a pointer pointing to that struct property. All right, so we've gone over most of the common data structures. Now let's get a little bit into conditionals, so if-else statements. And this is really simple. These are the same as they are in most C syntax languages, but let's return 0 here, and then I'm going to have a function called, well, actually we'll create the function first. So we'll go up here, let's create a function, we'll call it guess number, and that's going to take in an argument of, let's say, num, that's going to be I32, and we're not going to actually return anything, it's just going to print, so it's going to be a void function. And then I'm going to test, let's say if, and I'm going to say if that num that's passed in is equal to 7, then I'm going to print a string of you guessed correctly, and then we can do an else. And I'm kind of assuming that you guys know like a basic if-else in some other language. So if not, let's say please try again. All right, and then we'll come down here and let's put in, let's say guess number, and then we're going to pass in 3. So you can see we get please try again. If I were to add a 7, we get you guessed correctly. Now, this is kind of crazy, but they actually haven't, as far as I can tell, they haven't implemented angle brackets yet. So if I say like if num is greater than 7, I get this invalid character error. And I actually went into the issues. Let me see if I can find it here. So if we look at comparison, I think it's this one here that I just looked at. Yeah. So the Explorer, both local and on Godbolt, are giving an error that they do not recognize the less than character. So you can see they're getting the same error. So we didn't implement comparison operators yet because we were wanting to do it just once. Okay, and you can look through this if you want, but basically we can't do the we can't use these comparisons. We can't do less than, greater than, or greater than or equal to. We're going to get these errors. So that's why I did just the equals here. Okay. Yeah. So if else, pretty simple, but again, you just can't use the greater than or less than, or even the not equal to. I think we get the same type of error if we do that. All right, so the next thing I want to show you is a match. So a match is pretty much a switch in other languages. So what we're going to do is get rid of that, and let's get rid of that. I want to create another function here, but I'm going to call this one lucky numbers. And that's going to take in a number, and let's return. We'll say we want to return I32, lucky numbers. Let me just get rid of that extra E. All right, so I basically just want to pass in a number, and if it's 7, 11, or 12, which are actually my lucky numbers, I always play when I play roulette. If it matches one of those, then it's going to say that is the lucky number. If not, then it'll say it's not. So we do this just like you would use a switch statement. We say match. Okay, so match, and what we're evaluating here is the number. So let's say number. Whoops, what is wrong with my keyboard or me? So we want to match the number, and then we say the case. So I'm going to say in the case of 7. Then we want to use a fat arrow here, and then we'll just print. And let's say. We'll say 7 is a lucky number, and then we'll just return from this, we'll return the number, and then we'll just copy this, and I'm going to do the same thing if this is 11, oops, not 1, 11, or if it is 12. Okay, so it'll print those if it's 7, 11, or 12, and then we just want to add our default, just like we would with a switch. So default, and let's print out. Let's see, we'll go ahead and add the placeholder here, and we'll say is not a lucky number. And then we just want to pass in here the actual number. Okay, and then let's also return the number from here. All right, now what we'll do is down here we'll call the lucky numbers function, and let's pass in 7. Could not resolve number. Oh, I'm sorry, I called this num. So let's change that to number. And we get 7 is a lucky number. If I pass in 11, same thing. If I pass in 10, we get 10 is not a lucky number. So if you have multiple cases for some kind of condition, then you can use a match. All right, so next thing we're going to do is a while loop. We're going to look at iteration here. So let's get rid of this and get rid of this whole function. And we're just going to write it in here. Now, again, I can't use greater than or less than, so it makes this a little tricky. The syntax, though, is going to be pretty much the same as most other C syntax languages. And you can look at the examples, like Explorer. I think that there's an example. Yeah, right here, while. Go to basic. Oh no, they use not here. That's actually what I'm going to do. But there is, I thought they had an example with a greater than. Maybe that was the for loop. There is no for loop here. Maybe that's why. Anyways, let's go back into here. So I'm just going to basically say if the variable is not equal to 0, then we want to decrement, and we'll count down to 0. So we'll create a variable. Let's say var I, set I 32, and set that to, let's set it to 11. Okay, and then I'm going to add a while loop here, basically doing what you just saw in the documentation, where we say while not. So while it's not, and then I is equal to 0. So while not equal to 0, then I want to decrement. So we're going to say I equals I minus 1. Okay, and then we'll just print out here, and let's print out, say, number, and then 0, and then we just want to pass in I here. So let's see what we get. And it's going to go to 10, because remember I set it to 11. And then it's going to check to see if it's not equal to 0, which it isn't. It's equal to 11. Then it's going to take 1 away, and it's going to print out number 10. And then it's going to keep going, because until this is true, once it hits 0, then it'll stop. Okay. But yeah, I can't do, like, at least at the moment, I can't do something like that. And I can't do I couldn't find an example of a for loop either. So we're going to skip that. And then I want to talk about generics real quick. I know generics are kind of advanced for a lot of people, but we'll just kind of look at it in the most simple way that I can. So generics are a mechanism for writing parameterized code that applies generally instead of making near duplicates for similar situations using the same code for different types. So I know that might not make a lot of sense, but let's say we have, for instance, a function, let's say get int, and it's going to take in an int. So we'll say I32, and it's going to return I32 as a type, and let's say return x. So it's just passing in what it takes in. Okay, and then let's say we want the same thing for a string. So we'll say get string, or let's just do get str, and let's say we pass in x, which is going to be a string, and then it's going to return a string, and then we're going to just same thing, return x. Okay, so I could come down here now, and let's say print. If I want to do the int, then I'll have to just do this, and then I can call get int, and whatever I pass in here, let's say 100, then it's going to print 100. If I want to use the string, I could say print, and I'll just do it. No, we'll say get string, and let's pass in a string of 100. So now we should get, oops, sorry, that's str. So we should get 100 from this and 100 from this. And let's say we have even some other types. So instead of creating these multiple functions that do the same thing but have different types, we can use a generic. Okay, and to do that, we would come down here and create our generic function. Let's call this getVal, because it could be any type, since we're using a generic, and the format for this is going to be some brackets, and then we want to use uppercase T, and then exclamation space type. So basically, T is it's a placeholder for the type, and it doesn't have to be T. You could use anything. That's the convention, though. And then we have what we're passing in, which is going to be X with the type of T. Okay, and then we want to return T. So this could be anything, right? It's basically a template. And then we just want to return X. So this is doing the same thing as these two, except we can pass in any type we want. All right, so let's come down here and let's say print, and we'll do, actually, you know what, I'll just copy both of these, and let's change get int to get val, pass in an int, and then change this to get val and pass in a string, and you'll see that it does the same thing. All right, so that's the easiest example I could come up with to explain generics. It's basically like a template so that you don't have to have multiple functions to handle multiple types. And if you're a JavaScript developer and you don't have experience with TypeScript, which does have generics, then this might seem a little weird to you because you don't deal with types in the first place. All right, guys, so I think that's going to do it for now. If there's other stuff you want to learn about that I haven't gone over, you can look in this Explorer/test data. I mean, I've went over most of it, arrays, classes, global variables, but there's other examples too. Like if we look at class, you have quite a few examples here. And also if you go to, where is it? Explorer. No, not Explorer. That's where we just were. Docs, and then design. And let's say you want to learn more about generics. You click here and go to like overview. And there's a lot of information here. So this is where I learned everything. And there were a couple other articles that I looked at as well. But yeah, so just keep in mind, this is experimental. This isn't something you're going to find a job doing tomorrow or even a few months from now. So just keep that in mind. I just wanted to do this because I was interested, and whenever I jump in and I learn something, I feel like I want to, teach everyone else what I've learned in a more compact way than having to come here and read over all this. But that's it, guys. I hope you enjoyed it, and I'll see you next time.